Hello everyone, my name is Vincent Cavé and I'm here to present Spreadsheets on interactive surfaces breaking through the grid with the pen. This work was done with Caroline Appert and Emmanuel Pietriga from Université Paris-Saclay. The grid is a central element of spreadsheets because it covers the entire workspace, arranges the values and provides a level of abstraction that allows seamless interaction with groups of values. But this grid forms a layer above the values that intercepts most of our actions. And while this is fine on the computer, since we have a multitude of input modalities to compensate for this, on an interactive surface with direct interaction, it is source of friction. When we want to interact with the grid, navigate above, reach the cell values underneath, and go back and forth between these layers, our misinterpreted actions slow down the workflow. Now, in order to understand precisely the issues to address, we looked into what users can do with spreadsheet programs on interactive surfaces through a systematic analysis, and then we looked into what they could do with those programs through an elicitation study. For the systematic analysis, we cross-compared 3 of the most famous programs, Apple Numbers, Microsoft Excel, and Google Sheets, in various operating systems and on various pen plus touch devices. Then we documented the operations triggered by basic actions, such as tapping with finger or pen, dragging with finger or pen, etc. It allowed us to confirm the existence of friction between the grid layer and navigation layer, and between the grid layer and value layer. We also observed a lack of consistency between configurations, revealing little agreement among interface designers. For instance, moving the finger will sometimes move the workspace, sometimes move the selection, sometimes initiate a new selection, and sometimes enlarge the selection. A double tap with the pen will sometimes place a cursor at the end of a value, sometimes in the middle of it, and sometimes select the whole value. The only consensual design choice we've observed is that two-finger interactions are always dedicated to pan and zoom navigation. But apart from that, there's no clear model for selecting elements, even though this is key to any direct manipulation technique. With the elicitation study, the aim was to understand the strategies users could adopt to perform a list of 28 common spreadsheet operations of selection and manipulation, both on the value layer and on the grid layer. So 16 participants were faced with the interface you see on the right, on a Wacom interactive screen, and they had to show on the left image the actions they would take to provoke the operation represented on the right image. They were free to use one hand, two hands, either end of the pen, and each time they had to note whether they thought their action was a good match and whether it was easy to do. And after this phase, there was a second phase where they reviewed all of their answers and had the opportunity to modify them. After encoding all of this, we observed that there was very little agreement among users regarding gestures, but that some principles could be drawn regarding modalities. Firstly, pen and touch are often considered interchangeable by participants, so modality alone can't distinguish between interactions aimed at the grid layer and interactions aimed at the value layer. Two exceptions are the selection of values and the deletion of elements, both of which are almost systematically performed with the pen. For selection, certainly because the tip of the pen allowed for higher precision, especially when selecting part of a string or a single character, and for deletion, they used the other end of the pen for the eraser analogy. Also, participants rarely use custom marks, and when they did, there were simple marks like circles, arrows, V-signs, and zigzags, and no two participants proposed the same mark. These marks could be useful as shortcuts for expert users, but our participants did not spontaneously propose to use them. In the end, there was very little use of pen and touch together, and virtually no use of multi-touch, since, as we saw before, multi-touch is always used for navigation, and our list of operations focused on selection and manipulation. Taken together, these two studies established one thing. There is little agreement about how to use pen and touch to interact with spreadsheets, whether it be among interface designers, among users, or between designers and users. So we took this opportunity to propose a set of interaction techniques leveraging the pen to mitigate friction between layers. And we built it on these 4 design principles. We employed simple gestures like tap, double tap, and drag. We limited mode switching between selection, manipulation, and navigation modes. We assigned consistent roles to pen and touch for a richer model. And finally, we were careful that our model is compatible with both mobile and stationary tablets, so that users don't have to learn a new model when switching from one to the other. To mitigate friction between the grid and value layers, we first tackled the selection issue. In the elicitation study, there was not a clear difference between pen and touch to interact with the grid or value layer, but there was a strong tendency to use the pen for value level selections inside cells. So we make the choice to have all selections performed with the pen. Tapping on a cell or dragging across cells selects at grid level, while drawing a mark within the boundaries of a cell selects at value level. And as participants propose a variety of marks to do that, we adopt a relaxed strategy, where users can underline, circle, or draw a rectangular shape. Making such a selection at value level displays not only the selection, but also what has not been selected, to allow further manipulation. Of course, we often want to select multiple elements. At grid level, we propose to do that with pen and touch, by holding the current selection with non-preferred hand, while adding or removing cells with the pen. And at value level, we propose to do that with the pen by applying to a range of cells the logic behind the selection of a subset of strings. In this example, we selected every character before the first comma and generalized it to the whole column with two simple gestures. As all selections are made with the pen, the fingers are available for most manipulations, like in this example for moving cells at grid level. But for some manipulations and values, fingers are not precise enough, so we assign them to the pen. In this example, fingers are fine to split a column in two, but the pen is better to move a small selection at the end of a cell. Operations like this are just not possible with today's spreadsheets, even on computer, without having to apply functions or go through scripts. Here, they can be done by direct manipulation with fast and simple interactions. This model also allows simple editing. By drawing a small vertical mark, users place a text caret and can insert characters through handwriting. And by doing a short dwell, they can edit a single or multiple value level selections, which would otherwise require a significant amount of work. Now, to mitigate friction between the grid and navigation layers, we designed two types of widgets. We named the first one the mini table. It shows a small overview of the dataset and lets users see rows and columns that are beyond the viewport. It also allows them to scroll to a distant location and facilitates the manipulation of elements that are far away, relying on pen and touch. Users can also use it to select ranges of rows and columns, reducing the need for endless panning through the dataset. The second type of widget is mini-visplots. It shows the distribution of values in respective columns. And while the mini-table allows operations that are more grid-based, mini-visplots help users see and select elements that are value-based. Still using the pen for its high motor precision and its limited visual occlusion, users can interact with bar charts, density plots, and box plots instead of actually navigate the table, further reducing the friction between grid and navigation layers. In order to observe users' ability to appropriate the proposed techniques, we carried out a semi-structured qualitative study. 6 participants, after a short interview and a demonstration of the techniques, worked on their own datasets for 45 minutes while thinking aloud, and filled out a questionnaire about their experience. To sum up, they were generally satisfied with the model regarding the basic operations they knew very well, like selecting cells, moving rows and columns, and they were rather efficient at going back and forth between these techniques and the new ones that we proposed. They used the widgets a lot, but for various purposes and in various proportions, depending on the participant. They were quickly fluent with value level selections and manipulations, and were able to make elaborate transformations from value editing to table reshaping. And finally, maybe the finding we are the most proud of, they were able to create meaning from their data that they hadn't been able to do with their conventional tools. So by no means our set of interaction techniques represent a complete solution for working with spreadsheets on interactive surfaces, but we hope to have shown how the pen can be used to disambiguate between layers by letting users break through the grid. Thank you for your attention.